This scene looks like the future, right? You've got solar panels quietly doing their thing, electric cars charging in the driveway. It's the very picture of clean energy progress. But what if you could peel back the manicured lawns? What you'd find is an electrical grid that was designed for the last century. It's basically an analog system struggling to keep up with our very digital, decentralized world. So the critical question isn't if we'll adopt these new technologies, it's whether the silent infrastructure right under our feet can even handle them without breaking.
Well, to solve this exact problem, a new proposal has been submitted to the U.S. Department of Energy. It's called the Fathom Mesh, and honestly, it's a fundamental rethinking of the suburban power grid. So in this explainer, we're going to break down what the Fathom Mesh proposal is all about. We'll explore its design, how it works, and its potential to, unlock our clean energy future.
All right, here's our game plan. First, we're going to dig into the core problem, what's stressing our grid out so much. Then, we'll properly introduce the Fathom Mesh and see how its hardware and software work together. After that, we'll look at the real-world benefits, like how it boosts resilience and efficiency. And finally, we'll lay out the step-by-step plan for making this whole vision a reality.
So, to really appreciate the solution, we first have to get a handle on the scale of the challenge. I mean, why is our current system, which has worked pretty well for a century, suddenly under so much stress?
Okay, so the fundamental issue is this. Our grid was built on a super simple 20th century model. Think of it like a one-way street. Giant power plants generated electricity and it just flowed in one direction, right to you, the consumer, at the end of the line. It was predictable, it was reliable, for its time. But that predictable one-way world is just gone. Today, that one-way street has turned into a chaotic two-way highway. During the day, you've got thousands of homes with solar panels acting like mini power plants, and they're pushing huge amounts of energy backwards onto a grid that was never, ever designed for that. This causes all sorts of problems, like voltage instability. Then, as soon as the sun sets, the complete opposite happens. Everyone gets home, plugs in their EVs at the same time, and creates this sudden, massive demand spike that strains the entire system.
This daily roller coaster of supply and demand actually has a pretty famous name, the duck curve. And you can kind of see why, right? The deep belly in the middle of the day, that's when solar power is flooding the grid, but nobody's really home to use it. Then the steep ramp of the neck, that's that critical moment in the evening when the sun goes down, just as everyone gets home, plugs in their cars, and turns on all their stuff.
And let's be really clear, this isn't just some technical problem for engineers to worry about. As the Fathom Mesh proposal puts it, pretty bluntly, solving this is critical because it is the bottleneck to decarbonization. Just think about that for a second. The very tools of our clean energy transition, our solar panels and our EVs, are creating a problem that could actually bring that whole transition to a grinding halt.
So, with the problem clearly defined, let's talk about the proposed solution, the Fathom Mesh.
The Fathom Mesh comes at this with a two-layered solution. At the bottom, you have the physical architecture. This is the actual hardware, the advanced wiring and nodes that make up the grid's new foundation. And then layered on top of that is the logical architecture, an intelligent software layer that acts like the brain, orchestrating the flow of energy across that whole physical network.
So, let's dig in and see how these two layers, the hardware and the software, actually work together. What is it that makes this system so different from the grid we have right now?
All right, the key piece of hardware here is something called a solid-state transformer, or SST. Now, this is not your grandpa's humming green utility box. A traditional transformer is a passive device. It just sits there. An SST, on the other hand, is an active, intelligent energy router. It's constantly managing voltage, filtering out electrical noise, and, this is really important, it can isolate faults in real time to stop cascading failures in their tracks.
And this is where the software really gets clever. Okay, look at the daytime scenario. Solar House A is making more power than it needs. Now, instead of pushing that energy all the way back to a substation miles away, the software uses those SST energy routers to send it directly across the street to neighbor B. Now, fast forward to the evening, an EV is plugged in. The system is smart enough to pull power from a nearby home battery to meet that demand, right there, locally. It's peer-to-peer energy happening in real time.
So what this software layer is creating, really, is a dynamic, hyperlocal energy market. The core idea is simple, but it's incredibly powerful. Use energy as close to where it's generated as possible. This totally minimizes the wasteful process of sending electricity on a long round-trip journey to and from some distant substation.
This all sounds great in theory, but what does it actually mean in practice? Let's talk about the real-world impact this would have on grid resilience and efficiency.
Okay, maybe the most impressive resilience feature is something called amphibious mode. Imagine a huge storm knocks out power to the main grid. With a traditional system, boom, everyone goes dark. But with the Fathom Mesh, a whole neighborhood cluster can instantly and automatically disconnect, creating its own self-sufficient energy island. It just uses its own local solar and battery storage to keep the lights on, completely independent of the bigger blackout.
This diagram shows you exactly how that works. See how the connection to the central substation is severed? The local cluster is now operating entirely on its own, sharing power among itself. For the people who live in these homes, an outage that might have lasted for days suddenly becomes a total non-event. The goal here is to get to near zero power interruptions from any upstream failures.
Now, beyond just resilience, the efficiency gains are huge. Every single time electricity travels down a wire, some of it is lost as heat. It's called thermal loss. By keeping power local, the Fathom Mesh just avoids those long, inefficient round trips to the substation. The proposal estimates this could cut those losses by 30%. That's a massive amount of wasted energy that's now being put to good use.
And the savings go beyond just energy. I mean, think about the biggest reasons for power outages. Storms, high winds, falling tree branches, all of them messing with those vulnerable overhead power lines. The Fathom Mesh is designed to be buried underground, making it pretty much immune to all that. The result? The proposal projects a potential 40% reduction in annual operations and maintenance costs for utilities. That's money that's no longer being spent on storm repairs and constantly trimming trees.
A bold vision like this needs a practical plan. So the final part of the proposal lays out a really clear roadmap for how we could actually build this future grid.
The deployment roadmap follows a pretty logical three-phase approach. You can think of it as crawl, walk, run. Phase 1 is the physical pilot. Just get the resilient underground hardware in the ground. Phase 2 is the transactive stage. Turn on the software and create that local energy market. And finally, Phase 3 is when you achieve full autonomy, which enables all those advanced islanding and grid-forming capabilities we just talked about.
And crucially, the whole system is designed to be future-proof. The SST nodes are modular, which means they can be physically upgraded as homes in the future demand more and more power. And the software is built on open standards, so it's tech-agnostic. It doesn't lock utility into one brand of battery or EV charger, making sure it can adapt to whatever technology comes along next.
So we end up right back where we started. The pieces of our clean energy future, they're already here. They're sitting on our rooftops and parked in our driveways. The central challenge, and the one the Fathom Mesh is designed to solve, is whether we have the underlying infrastructure that's smart enough, resilient enough, and dynamic enough to connect it all together.